Let's determine how much sodium azide is necessary to produce enough nitrogen gas to fill out an airbag that has a volume of 7.95 liters. Now, so the mass of the sodium azide is what we're trying to find here. Let's write it down. This is our unknown. But we have some data for the nitrogen. So let's put what we have. For the nitrogen, we have, let's put everything here. So N2 and everything here relates to nitrogen. We have the volume. So the volume is 7.95 liters, which is the volume of the airbag. And we also know the pressure, 1.2 atmospheres. And we know the temperature, but we're just going to convert these to kelvins at once. So at 273, so we have 296 Kelvin. Now, how we're going to find the mass of the sodium azide? First, we're going to use the mole ratio to determine the moles of the sodium azide, knowing the moles of the nitrogen. So let's put it here. Once we have the moles of the nitrogen, we can use the mole ratio and we can find the moles of sodium azide. So it's 2 to 3 ratio. Now, once we do that, we can find the moles of the sodium azide, and then we'll have one more step to do, which is convert the moles of the sodium azide to the mass of the sodium azide, and here we're just going to use the molar mass. So step 1, how do we find the moles of the nitrogen? Volume, pressure, temperature. And so this is one step, pretty simple. We're going to use the ideal gas law equation, PV is equal nRT, and from here we're going to determine the moles. N is equal to PV over RT, and we're just going to put the numbers here. So we have 1.2 atmospheres times 7.95 liters. I'm going to divide this by the R, so 0.08206. I'm going to skip the units, times the temperature 296, and if we do all of this math here, we'll have 0.393 moles. Okay, so this is for the nitrogen. Now what we're going to do, we're going to put this number, the moles of the nitrogen, on top of it in the chemical equation so that we can use the mole ratio to find the number of the moles of sodium azide, which we're going to do based on the mole ratio. So mole ratio here is going to be determined based on this number. So 0.393, this is the moles of the nitrogen, and based on the mole ratio, we can write down that the moles of the sodium azide is equal to 2 times 0.393 divided by 3, and this will be the moles of sodium azide. So let's multiply and divide. We have 0.262 moles of sodium azide. Let's put here 0.262 moles of sodium azide, and we only need to do one more step. So here we're going to use the molar mass, M, to find the mass of the sodium azide. Sodium azide, so this is equal to the moles times the molar mass, 0.262 multiplying by the molar mass, which is 65 grams per mole. And this gives us, cancel the moles, we have 17.0 grams. That's how much sodium azide will be necessary, will be required to produce 7.95 liters of nitrogen under these conditions.